Hello and welcome to GI Physiology. Today we're going to be talking about the pancreas and the biliary system. So first let's see where the pancreas is, what it does, and what it looks like. So the pancreas is below our stomach, as I've drawn right here. In red, this is the pancreas. In green, it's the bile ducts. And our stomach, and this is our duodenum here. So the pancreas empties secretions into the duodenum, as you can see here. There's the exocrine secretions and the endocrine secretions. The exocrine secretions enter the GI at the major ampulla. So the major ampulla would be right here, where the bile ducts are entering. And it is also called the ampulla of Vater, but you'll probably mostly see major ampulla. And the major ampulla is controlled by the sphincter of Oddi. The flow is controlled by the sphincter right here. And then we have the endocrine secretions that go into our blood through the pleural vein. So here's in the blue, it shouldn't be blue, but it's supposed to be the blood, and the hormones would be coming from here and into the blood and going in. The hormones would be like insulin and glucagon. Those are the hormones that we're going to have coming out of the pancreas. So the major goal of the pancreas is to neutralize gastric juices, and also it's to add digestive enzymes for fat breakdown, protein degradation, polysaccharide degradation, and others, but we're mostly going to focus on the fat, protein, and polysaccharides. And we're not going to go into the others, but there are other things that the pancreas does break down. So how do we get these secretions? So here I have written that it's similar to the salivon, as we saw in our salivary sections. Right here we have the acinar cells and the ductal cells. This right here is called the blind sac lined with acinar cells here. And then we have in the salivary we call them duct cells, but here we have the ductile lined with centroacinar cells and columnar epithelium here. And all small ductules drain into progressively larger ductules, as you can see in the picture. And now we're going to go more in detail about the centroacinar and ductal cells and what they produce. So the centroacinar cells and ductal cells produce the bicarbonate solution. Our bicarbonate solution is made from carbon dioxide and water reaction to the lumen via the chloride and bicarb antiporter. And as we remove more protons, the bicarbonate increases, and then it gets transported out of the cell and into the lumen. So that's really important to remove those protons. If we don't remove those protons, then the bicarbonate won't be increased. And also, it's important to know that it's almost, the solution is isotonic to plasma at almost all flow rates. There's this very small change, but it's not a huge jump at all. So at low flow rates, we have the sodium, we have less bicarb and more chloride. And at high flow rates, we have more more bicarbonate, so we have at higher rates, we have more bicarbonate and less chloride. I can draw a little graph here. So here's our graph here to depict what I was trying to say here. So here we have low flow rates and we have more chloride and less bicarbonate than we normally would. These are supposed to be straight lines, so this is not declining, and neither is this. Sodium. So sodium and potassium stay the same, but just a little bit of jump. It's not even a huge at all. As flow rates increase, there's going to be more bicarbonate and less chloride, as you can see right here. So there's the relationship. And also, our centroacinar and duct cells are stimulated by secretin and potentiated by CCK. Secretin and CCK individually stimulate, but once they are combined, they stimulate a lot more, and that's because the CCK is a potentiator. So let me just draw that. Maybe it's easier to see in a graph. So here I have that graph. So here's just the secretin alone, which it would still stimulate, but not as much. And then we have the CCK a little bit lower than secretin, but when they're together, it's much, it's stimulated way a lot more. And just to add on to the transport of the bicarb and the chloride here, this is one of our cells here, and here's the lumen out here, and we would have the chloride bicarb antiporter here, bringing the chloride in and the bicarb out. And then we would have a chlorine channel here. Draw that in blue. That would take out. This would take out our chlorine that comes from here. Just so you have a visual of it. So now that we know how we produce it and how much is in our centroacinar, the concentration of it in centroacinar and ductal cells, there we have to know the regulation of these secretions as well. So we have the hormonal regulations and the neuronal as well. So here I have the hormonal regulation listed. And so here we know that as the pH is low, there's an increase in secretin, which increases the secretion of bicarb. And as we talked about here with the CCK is a potentiator, but it's also known that insulin also acts as a potentiator as well. But this is not as important in animals and cats and dogs. Also, the CCK stimulates the enzyme component and increases their transcription. Also, there's the gastrin. This is not a positive fact here. It's still under research, but the gastrin is known to